Okay, in this video, I'm going to show you on how to run and read the SPSS outputs for correlation and regression. Okay, previous lesson, we already looked at on how to calculate Pearson correlation and how to get the regression equation using formula. Okay, now we're going to learn on how to use software, which is SPSS. So SPSS stands for Statistical Packages for Social Science. Okay, here I have example. So this data about between variables age and time. Okay, so it is about an observation was carried out to determine the relationship between the age of a chef and the time in minutes needed to prepare a dish. So the table below shows the data recorded by 8 randomly selected chefs. Okay, now I'm going to show you on how to use SPSS in order to get value Pearson correlation and the estimated regression equation. Okay, so this is interface for SPSS. This is older version 16. Later on, I will give you the link if you want to try how to run data using SPSS. So basically, SPSS, it has two windows here. Okay, so here is variable view. This is variable view windows, and the first one here on left hand side here is data view window. So this is where we store our data. Okay, first we need to key in our variables. Okay, so this is columns for details for our variables. Okay, for example, name is name for our variable. Okay, example data just now we have between age and time. So here, which one is X independent variable and which one is independent variable X and which one is dependent variable Y. So basically we will say that time to prepare a dish will be depend on age. Okay, so time will be Y dependent variable and age will be X independent variable. Okay, so we key in data, these two data means that X and Y into SPSS. Okay, first variable age. Okay, so give variable name age. Second one is time. Okay, type means that what are the type of variables. Okay, so age in numerical, so will be numeric, and time also will be numeric. So if your variable is non-numerical, you set it as string. Yeah. Okay, let's say our variable is non-numerical, so you set it as string. Okay. Okay, decimal here you set equal to 0. Means that how you're going to display your data in how many decimal point. Okay, example, age I set 0, time I set 2, right? So in data view, let's say if we put the data age 2, for example, time 2. Okay, so decimal 0, later on in our data view windows, it will appear as 2 only. But when you set the decimal point equal to 2, in data view window, it will appear as 2.00. If you set it equal to 1, then it will appear as 2.0. Okay, so the rest no problem. So the most important column for variable is name, type, and decimal here. Okay, then go to data view window, key in our data, age 23, 45, 34, 50, 44, 29, 36, and last one 52. Okay, time 63, 52, 55, 54, 50, 60, 57, and last one 50. Okay, now we already key in our data, value x and y accordingly. Okay, how to get value Pearson correlation? Okay, you go to analyze and then go to analyze, correlate, bivariate. Okay, so this is value R. Bivariate means using two variables, x and y. So click bivariate. Okay, put these two variables, age and time, into column variables. Okay, correlation coefficient, so you click for Pearson. Okay, so the rest ignore because it already set for you by default. Okay, then just click OK. So this is output SPSS for correlation. Okay, so value correlation R is negative 0.901. Okay, so this is also value Pearson correlation, negative 0.901. Okay, you just need to know how to read this value. Okay, so be careful, SPSS, if value start from 0 point something, it will put 0.901. Okay, means that value 0 in front of decimal point will not be displayed. Okay, this table, it gives you in matrix form. Okay, so that's why here Pearson correlation each here equal to 1 because with itself, each and each. Okay, so that's why the correlation is 1. So this one between each and time, so the correlation is negative 0.901. So if you look at second row here, time and age. Okay, so between age and time and age also the same thing. So that's why the value of correlation also the same. Okay, this one time and time, so within itself, so that's why the correlation equal to 1. Okay, so that is correlation output on how to read value Pearson correlation. Okay, now let's look at on how to get the estimated regression coefficients, value A and value B. Okay, how to get A? Go to analyze, go to regression, and then you choose linear. Okay. Okay, now we need to know which one is x, which one is y. So dependent is y, so y just now is time. So insert time into row dependent, and then independent variable age. Okay, so the rest statistic and all this one already set by default, so you just click OK. Okay, under regression output, it will give you 1, 2, 3, 4 tables. Okay, 1, 2, 3, 4 tables. Okay, for you all just need to know to read these two tables only. Table model summary and table coefficients. Okay, look at table model summary first. Okay, R here to indicate value for Pearson correlation. So notice that here in SPSS, under output regression, it will show you absolute value of R. Means that if value R is negative, under regression output, it always shows positive value. So if you look at here just now, value correlation is actually negative, right? But under regression, it will show absolute value of R, means that it will show positive value. Okay, let's say in exam, table correlation here is not given to you. So how to know value R is positive or negative? Okay, later on, you look at table coefficients here. Okay, so after this I show how to read this table. Okay, look at this one first, value R square. So R square is value coefficient of determination. So how to get value R square? We square value R. Okay. So 0.901 square, we will get 0.811. So be careful here. Here you have decimal point. So means that 0.811. Okay. Okay, from model summary table, only these two columns that you need to know how to read the value. Okay, now look at table coefficients here. Okay, here you have constant and h. Okay, so constant means that value a. So recall regression equation y equals to a plus bx. So constant here referring to y-intercept value a. Okay, then h, our independent variable. So here will always be the independent variable. So h, value b here referring, b is actually in statistics is for beta. Okay, so this is value a, y-intercept, and this is value b, value slope or value gradient. So from table coefficients, value that you need to know is only this column only. Okay, so the rest ignore. So you only need to know this one. So from this table, what is the regression coefficients? So here y equals to a plus bx. So from the estimated coefficient, y equals to 71.133 plus bx, right? Okay, now our slope is negative. So the equation will be y equals to 71.133 minus 0.409x. Okay, back to value r just now, absolute value of r. So recall, correlation just now is negative, right? So as this table show absolute value of r, means that if original value r is negative, it will always shows positive value. So if you only have regression outputs, how to determine whether r is positive or negative? So you look at value slope. Okay, so value slope negative to indicate that r is negative, means that the correlation is negatively correlated. Okay, so remember how to know value r here is positive or negative. Look at value slope here. So if slope is negative, meaning to say that value r here will be negative. If slope is positive, value correlation here will be positive. Okay, now look at in detail. Okay, just now table correlation negative 0.901. So these two values will be always the same, okay, because it is a mirror image. This is in terms of matrix, okay. So how we calculate this value, how to get this value using formula Pearson correlation here. Okay, table model summary, as I said before, you just need to know how to read these two columns only. So R is Pearson correlation, R square is coefficient of determination. So remember here, this one will always give you positive value of R. So how to know it is positive or negative? We look at table coefficients. Okay, so if slope is negative, means that R will be negative, and otherwise. Okay, this table, ignore the other columns. Okay, so you just need to know how to read this column only. So constant here, value A. So how to calculate value A? Using formula y-intercept. Summation of y divided by n minus b multiplied by summation of s divided by n. So this is value slope. How to calculate value negative 0.409? Using formula slope. Okay, so this one will be our independent variable. Okay, now let's look at example of question based on the SPSS output. Okay, look at A. Identify the independent and dependent variables. Okay, previously I give you one tip on how to identify the independent and dependent variable correctly. Okay, you can look at prediction or estimation question. Okay, so here prediction question is on question E. So estimate the time needed. Okay, so remember in regression we want to predict y, the dependent variable. So estimate the time needed, so time will be the y dependent variable. Okay, that is one tip. Or second one, you can use output from SPSS. Okay, so you can refer table coefficients here. So here constant, so under constant here second row, this one will always our independent variable. Okay, so if you have SPSS output like this, so you can refer here under table coefficients. Here will always our independent variable. So independent variable will be age. So y will be the time to prepare the dish. Okay. Okay, B, prove that the product moment correlation coefficient is negative 0.901 and explain its meaning. So how to get this value, negative 0.901? So again, we use formula Pearson correlation. Okay, so if question asks you to get this value, you use formula Pearson correlation. So how to get that value? Key in the data into calculator and you get summation values here, and then substitute into formula correlation. So from here we will get R equal to negative 0.901. Okay, explain its meaning. So if negative 9.01, so recall when we want to interpret correlation, we must take the direction and the strength. So if negative 0.901, there is a strong negative. Strong means that because 0.9, or if you put there is a very strong also, no problem. Okay, negative relationship between age of a chef and time needed to prepare a dish. Okay, C. Determine the slope and y-intercept of the regression equation, or maybe question asks you to prove value 71.133 and value slope negative 0.409. So how to prove this value? You use formula y-intercept and formula slope. Okay, so when you substitute the value into formula, you will get y equals to 71.133 minus 0.409 x. Okay, interpret the coefficient. So y-intercept A, so how we interpret A? When x equal to 0, y equals to A. Okay, so here I put A equal to 71.133 means that when age of a chef is 0 years old, the time needed to prepare a dish is 71.133 minutes. So recall previously I already explained that not all situation is suitable or necessary to interpret value y-intercept. Okay, depends on the problem given. Okay, here in this example, it is not appropriate to interpret value A or value y-intercept. Okay, why? Because when the age of chef is 0 years old, age 0 years old means that the chef is not born yet. Okay, so if not born yet, so how to prepare the dish right? Okay, so in this case, not suitable to interpret value A. Okay, value slope. How to interpret value slope? So recall slope. How to interpret? When we add 1 unit in x, y will increase or decrease by b unit. So if b positive, will increase. However, if b is negative, will decrease. So here slope b equal to negative 0.409 means that when age of a chef is increased by 1 year old, the time needed to prepare a dish is decreased by 0.409 minutes. Okay, so decrease because B is negative. Okay, write the complete regression equation. So as I said before, y equals to 71.123 minus 0.409x. Okay, last question, prediction question. Estimate the time needed for a chef who is 30 years old to prepare a dish. So age is variable x. So you substitute value x equal to 30 into regression equation here. So when age is 30 years old, the estimated time to prepare a dish is around 58.863 minutes. Okay, calculate coefficient of determination, hence explain its meaning. So coefficient of determination are square. We just simply square value Pearson correlation. So negative 0.901 square, we will get 0.811. Okay, so be careful here. When you have negative value, when you square it, it will always be positive. Okay, negative multiplied by negative, you will get positive. So be careful when you press your calculator. Okay, how to explain coefficient of determination? So recall coefficient of determination, how to interpret. How many percent total variation in y that can be explained by x using the regression line. Okay, here how many percent? So 81.1% of total variation in y. So our y dependent variable is time taken to prepare a dish. Can be explained by x. So x is the age. Okay, of chef using the regression equation. So means that by using this regression equation, the accuracy to estimate y dependent variable is around 81.1%. Okay, after this, I'm going to show you another example. But before that, I want to show you some statistic measure from SPSS output. Okay, let's say we use this data each and time. Okay, let's say we want to get the mean, mode, median, Q1, Q3, standard deviation, skewness, and so forth. So how to get that values? Okay, we go to analyze. So one way that you can get the statistic, okay, you click descriptive statistic and then you choose descriptive. Okay, so you put variable. So which variable you want? So let's say I just want variable age. Okay, you click option. So what are the values that you want? Okay, let's say if you want mean, you click mean. So by default, it will click for you mean, standard deviation, minimum, and maximum. So if you want variance, click variance. If you want range, you click range. Okay, minimum, maximum. Minimum, smallest data. Maximum, largest data. SE mean is standard error of mean. So this one, no need. Okay, distribution, skewness. So kurtosis, no need. So this is the measurement that you already learned. So you click continue. Then you just press OK. Okay, so this is the output. Okay, let's say each n referring to number of data. So statistic means that the value for sample. Okay, so statistic 8 means that value n equal to 8. Okay, each, what is the range? Statistic means that what is the value for that measurement. Okay, so 29. So how we get 29? Minimum minus maximum minus minimum. 52 minus 23, we will get 29. So minimum value is 23, maximum value is 52, mean so 39.12. So this is value x bar. Okay. So how you get 39.12? You total all data and then divided by n. And And then standard deviation is value S. So how you get this value? Use formula standard deviation. Then this is value variance 105.839. So how to get variance? Use square value standard deviation. Or if you have variance, how to get standard deviation? Use square root value variance. And then skewness. So value skewness is this one, negative 0.29. So standard error, no, you did not learn about standard error. So ignore standard error. Okay. So that's how you read some descriptive statistic from SPSS output. Okay, now look at example 2 here. Okay, Fizi owns a bakery shop. She has advertised in the shop through newspapers and magazine in order to persuade potential customers to consume more products. In an attempt to analyze the relationship between advertising costs and sales, she recorded a monthly advertising budget and sales that was coded in 100 for a sample of 12 months. The data are listed in table 1. Okay, so here we have data about sales in 100 and advertising costs. So sales is coded in 100. So in January, the value is 65. So if coded in 100, the actual value will be 6,500. Okay, so how you get 6,500? 65 multiplied by 100. Okay, so remember all this data for sales was coded in 100. Okay, Fizi used the SPSS software to analyze the data. Figure 1 gives the scatter plot of sales versus advertising, and table 2 provides the results of regression analysis. So this is the scatter plot. So Y is sales and X is advertising cost. So we would say that sales will depend on advertising cost. As more or the more we put on advertising cost, we expect sales will increase. Okay, look at question. Okay, A. From the scatter plot provided, comment on the relationship between advertising costs and sales. So first, you look at the scatter plot. So if you look at the pattern, the direction is to the right. Okay, so means there is a positive correlation. And then about the strength, okay, look at the data points. So here we can see that the data points falls or scattered closely. Okay, so here we can say there is a strong positive relationship between sales and advertising cost. So here we can put there is a strong positive correlation or relationship between advertising cost and sales. Okay. Okay, B, calculate the correlation coefficient and interpret its value. It means that value R. So here in this question, it only gives you table coefficients. So how to get value R? So first step, we need to key in this data into calculator. Okay, I show you using this calculator. The rest you can refer your notes on how to use your calculator. Okay, sales is Y, so sales is Y, advertising cost is X. Okay, press more, and then you choose regression, and then number 1, linear. Okay, this calculator, how to key in data? X, comma, and then Y. Okay, enter data, you press and plus. So example, X is advertising cost, 700, 65 and plus. So that is the first data. Okay, continue until last data. Okay, last data 310, 46. Okay, so altogether 12 data. Okay, then you extract the summation values. So you press shift 1. Okay, so we want all these values. Okay, we extract the summation values. So how to calculate Pearson? Substitute the formula Pearson correlation. So here summation of xy 220, 220 minus summation of x 4340 multiply summation of y 534 divided by n12 divided by square root of summation of x square 1964 800 minus summation of x 4340 square divided by n12. Then multiply by summation of y square to 5864 minus summation of y 534 square divided by 12. Okay, so to get value r, so again you can check directly from your calculator. So this calculator you press shift 2. Okay, so press right arrow here until you see r. So r is number 3, you press 3, press equal. So r is 0.94. Okay, interpret its value. So there is a strong positive correlation between advertising costs and sales. Okay, so it is proof that when we use coefficient of correlation also we get strong positive correlation. Based on scatter plot just now, we conclude that there is a strong positive correlation. Okay, question C, compute the values of V and W. So what are V and W? So if you look at this this coefficients table, V is value constant, which is value y-intercept, and Y is value slope or gradient. Okay, so how to calculate V and W? V we use formula y-intercept, W we use formula slope. Okay, in order to calculate value V or the y-intercept, we need to have value B first. Okay, then we can calculate value V. Okay, first calculate value W or value slope. So B equal to summation of xy 220, 220 minus summation of x 4340 multiply summation of y 534 divided by 12. Then divided by summation of x square, which is 1964 800 minus summation of x 4340 square divided by 12. Okay, how to get this value? We also can get it directly from calculator. Okay, press shift 2. Okay, so value B number 2 press 2 equal. So 0.0686. 0.0686. So that is value W. Okay, value V or the y-intercept. So A equal to summation of y 534 divided by 12 minus B, so 0.0686 multiply summation of x 4340 divided by 12. So how to get value A here? So again you press shift 2, this calculator, and then choose for number 1 value A. 19.7065. Okay. So that's how we calculate value V and W. Okay, D, interpret the slope of the regression line in the context of problem. So slope, how we interpret slope? When we add one unit in X, Y will increase or decrease by B unit. So slope here, slope D equal to 0.0686 indicates that for every ringgit, okay, why for every ringgit? Is that for every 1 unit? For every 1 unit increase in X, so our X just now is advertising cost, right? So this one in ringgit. So for every ringgit or for every 1 ringgit increase in advertising cost, Y will increase. So Y just now is sales, will increase. Since B is positive, so will increase by RM. Okay, be careful. Sales just now was coded in 100. So this one multiply by 100. Multiply by 100, we get 6 ringgit 86 cents. Okay. Okay, question E. Determine the coefficient of determination and interpret its values. The coefficient of determination is R square. So R just now is 0.94 Pearson correlation square. So when we square this value, we will get 0.8836. Okay, how to interpret? 88.36% of total variation in Y, so Y just now sales, can be explained by X, which is advertising cost, using the regression equation. Okay, so if we use the regression equation, so what is the regression equation? Y equals to 19.7065 plus 0.0686 x. So by using the equation, the accuracy to predict Y is around 88.36%, meaning to say that it is good, right? Okay, F, predict sales when 500 ringgit of advertising cost is allocated. So the regression equation just now is Y equal to 19.7065 plus 0.0686 x. So Y equals to 19.7065 plus 0.0686 and then substitute x equal to 500. Okay, so original value of x, advertising cost just now, was not coded in any value, so you just put x equal to 500. So Y equal to, so when we calculate this one, we will get 54.0065. So this value is actually in 100 ringgit. Okay, so if you look at original data, sales coded in 100 ringgit. So when we want to write the final answer, make sure we write in its actual value. So this one final answer will be equal to Y equal to RM 5,400 ringgit 65 cents. So this value you multiply by 100, you will get 5,400 ringgit 65 cents. Okay, that is example on how to answer question correlation and regression based on SPSS outputs.